All right, let's dive in. Today, we are going on a tour of the absolute fundamentals. We're talking about the building blocks of you, me, and literally everything in the universe. So let's get right to the one big question that starts it all.
I mean, really think about it. It's one of the biggest questions you can ask, right? And the answer is kind of wild, because it's both incredibly simple and amazingly complex. We're going to get to the heart of that right now. So here's the key idea, the atom. This is the smallest possible piece of anything that you can have. And I absolutely love this analogy. It's like the tiniest Lego block. You know, a single blue Lego is still blue, right? Well, in the same way, a single atom of gold is still gold. Okay, so our first stop on this tour is going to take us right into the very center of the atom. It's this dense, crowded place called the nucleus. Let's go meet who lives there. Here we go. This is our map for the whole journey. This little table shows our three key players, the proton, the neutron, and the electron. Now pay attention to their charge and, super importantly, their location. See that? Two of them are tucked away inside the nucleus, and one is way out on the outside. Let's start with the first resident of that nucleus, the proton. And here's the easiest way to remember this. It's right in the name. Proton is positive. It's got a positive electrical charge, and it's one of the heavyweights, just kind of hanging out right in the middle of the atom. Now, the proton's roommate in the nucleus is the neutron. And, you guessed it, just like its name suggests, a neutron is neutral. It has no charge at all. Its main job is to add some mass, and, this is crucial, it acts kind of like glue to help hold that nucleus together. Okay, so we've met the calm, stable crew in the core. Now let's meet the super high energy particle that's living life in the fast lane on the outside. And this shows it perfectly. An atom basically has two different zones. You've got that dense, stable center with the protons and neutrons, and then you have this huge outer region where our third particle is in constant, crazy fast motion. And here it is, the electron. It's got a negative charge, which perfectly balances out the proton's positive charge. But the thing that really defines it is speed. I love this memory tip. Just think e-zoom. These tiny particles are zipping around like crazy, and this is where all the action happens. How they move is what determines how atoms connect to each other to make everything, from water to you. So we have these three particles, right? But what's really interesting is that one of them holds the secret code, the actual identity of the atom itself. And that secret is called the atomic number. And it's so simple, it's almost beautiful. The atomic number is just the number of protons. That's it. It's like a permanent, unchangeable ID card for every single element in the universe. For example, if you find an atom and it has just one proton, it will always, always be hydrogen. Its atomic number is 1. It literally cannot be anything else. But if you find an atom with 8 protons, boom, you've got a totally different element. That's oxygen. Its atomic number is 8. That one number, how many protons it has, that's everything. All right, you've made it through the tour. Now let's make sure it all sticks. How about a quick rapid-fire round to lock the stuff in? I'll flash a question, you think of the answer. You ready? First up, the neutron. Think about its charge. It's the one chilling in the nucleus with the proton. You got it! Neutron is neutral. It carries no charge at all. Great start! Okay, next one. Where do we find that super fast particle, the electron? Perfect. Electrons are always in that big area zooming outside the nucleus. And for the final, most important question, which one of our three little particles is the atom's official ID card? Absolutely, it's the number of protons. That count is the atomic number, and it's the one thing that defines what an element is. And there you have it. That's your essential field guide. The positive protons are the atom's ID, the neutral neutrons are their partners in the core, and the negative electrons zoom around the outside. Simple, right? But knowing all this brings up one last fascinating question. So I'll just leave you with this final thought. If an atom's entire identity is locked into its proton number, what would actually happen if you could change that number? What are you really doing? Well, that's a question that takes us from chemistry into the wild world of alchemy and nuclear physics. Definitely something to think about. Thanks for joining me.